Hey again, Year 11s, and here's our next video on question 2. And the shout out this time is going to Jake. So there you go, Jake, that's your shout out. Okay, question 2. I'll let you pause here and read this, but basically we've got 4 graphs here, and we're going to be answering a couple of questions about these. So the first question says, out of the group shown above, which group has the most consistent times? So consistency is really talking about how tightly the starter's packed in. So I can immediately rule out these two. They're a bit more spread out than the other two. Canadian females seem to have a a shorter range, while Australian males seem to have a shorter interquartile range. And then if we took out those extreme values, the Australian males is actually tightly packed in, whereas the Canadian females is a bit more spread out. So I'm going to go with Australian males for this question, based on what I've just said really. So let's put pen to paper and get this down. So out of the groups, I'd say Australian males. Okay, now it says it gives statistical reasons for this. So we'll say since it has the smallest IQR, interquartile range, and if 3 extreme values are ignored, and we have to be very careful about ignored, but for here we're just saying if we just don't consider them for our distribution, what does that distribution look like? It's very tight. So that's all I'm saying there. I'm not saying we're taking them out completely. So if 3 extreme values are ignored, then it has the tightest, and we'll put that in inverted commas, tightest sample distribution. So what we mean by that is that if we look at the other distributions roughly, is Australian females, Australian males, Canadian males and Canadian females. Of all of those, the tightest one is definitely the Australians. All the others are much more spread out. Okay, how could Ella improve her investigation further? Well, there's several things that she could consider here, and the most obvious one to increase the confidence of her survey is to increase the sample size. So basically get more dots on your graph. So we'll maybe answer this in a bullet point style. So we'll say increase sample size. Okay, there's our first one. Basically to bring more confidence and reliability into our samples. So in order to have more confidence in her sample statistics and graphs. Okay, so that's one reason. What other reasons do we have? Perhaps we could consider the conditions of the test, of how the reaction times have been recorded. So we'll say check and modify test conditions in relation to measuring reaction time. Okay, just to make sure that so just to make sure that the results are consistent across the board. So in relation to measuring reaction times, and make sure conditions are consistent amongst different samples. Okay, what else could we do? Perhaps we could make sure that some other things are consistent, such as ages. If you picked a whole lot of old Canadians and a whole lot of young Australians, that wouldn't be very fair. So we could also say make sure sample covers a consistent range of ages from each country. And the purpose of that is just so that we don't get a whole lot of old people from one country, a whole lot of young people from one country. So we'll just continue that. So i.e. same number of people at each age from each country. Great. Okay, let's continue on here. Now I've got some probability questions here, and we've got a bit of a blah blah bit here that I don't have to pay too much attention to, but really we want to read the question. What is the probability that a student chosen at random from the sample has a reaction time of under 500 milliseconds? So here's under 500 milliseconds, so that's 97 plus 77, so that's 174, and that's out of a total all up of 200, so it's going to be 174 over 200, which we can simplify to 87 over 100. Okay, next question. What is the probability that a student chosen at random, get rid of those, was a female with reaction time of under 500 milliseconds? So under 500 and female is 97, so that's just 97 out of 200. 97 out of 200. Okay, the probability that a male student chosen at random from the sample had a reaction time of under 500. So now we're only looking at males, and we're looking at one that was under 500, so that's 77 out of a total of 85. So 77 out of 85. And our last question, if two students were randomly chosen from the sample, what is the probability that both of them had reaction times of under 500 milliseconds? So for the first one, we've got 174 out of 200, and for the second one, there's going to be one less, so it's going to be 173 out of 199, and that's going to give us a fraction of 30102 over 39800, which is a little bit difficult to understand, so putting it into a decimal is not a bad idea. So we could write that as 0.7563 if we wanted to. Okay, and that's the whole paper, so hopefully that gives you a good idea of how to approach this one. Thanks.